Okay, I told you guys I'd work some of these problems with you from the optional review. Let me make sure you know what is your assignment for tonight. It's this review for Unit 1, Test 2, and you have to do half of it at least. Try to do more if you can, and make sure to do problems from each section. So we're going to check that tomorrow. So maybe do number 1, number 3, and then when you get to number 5, do like A, C, E, that kind of thing. Kind of jump around and make sure you do half of it and at least some from each section. So the review we're going to work on today is this one right here. It says review worksheet. And when I look at this first one, I'm supposed to find all the roots. I might need to factor. So what I'm going to do is think about all the different possible roots I could have. So I could have 1 times 18, 2 times 9, 3 times 6, then I have 6, then I have 9, then I have 18, all over 1 and 2. And of course, I want to write all these out, but I need to make sure I recognize I could have some fractions in here. So let's go to the graphing calculator and graph it. And so here's my function, 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. And I'm going to graph it. And I'll show you, I played around with my window a little bit. In fact, I might even change my y's a little bit as well. So let me just do negative 10, 10, kind of zooming in. And then when I graph it, this is what I have going on. Okay, so it looks like I may have one at negative 1, maybe one at negative 3, and maybe one at 2. I'm not really sure what that one is right there. I'm going to go to my data table and find the whole number roots, and I have one at negative 3, negative 1, and 2. Okay, so going back to the graph, what is this root right here? So that's the question. It looks like it may be halfway between negative 1 and negative 2. So maybe it's just a negative 1/2. So I'm gonna see if that is it. So second calc, enter value here, and I'm just going to put negative 0.5, and then I press enter. That's not it. So maybe negative 1.5, because 3/2 is on our list. So let me show you what I mean by that. 3/2 is on our list because I could have a 3/2, and it would be the negative of that. Okay, so back to the calculator. So I'm going to do second calc, and I'm going to do value again. I'm going to do negative and put it in parentheses 3 divided by 2. May not matter with the parentheses, but it doesn't hurt either. And there we go. So that is my other root. Okay, now if I had not noticed that, I could have done synthetic division to find the right root. So let me show you what our roots were again. They were negative 3. I don't know why this won't let me do this. So I have a negative 3, negative 1, a 2, and then a negative 3/2. So let me make sure that's really what I had. So a negative 3, negative 3/2, negative 1, and a positive 2. So those are the roots. Okay, now let's do another one. Let's do number 3 here. When I look at this one, I notice that it actually would factor. So I could try to graph it and see what happens, but since I see that it factors, it's going to be quicker just to factor it and solve. So what times what gives me x to the 4th? Well, that's just x squared and x squared. And then I'm looking for factors of 12 that add to 7, and they would be 3 and 4. And because I need this to be an x squared, it's going to be 3x. And I'm sorry, just a 3 here, and then just a 4 here. And then when I multiply the inner and the outers, you'll see what happens. I get 4x squared and 3x squared, which adds to the 7x squared. So that's how you would factor that. And then what I'm going to do is I'm going to find my zeros by replacing f of x with 0 and then solving individually for each of these. So I have x squared plus 3 is equal to 0, x squared plus 4 equals 0. And when I subtract over 3, I get x squared is negative 3. And then I'm going to use square roots, positive and negative, and that's going to simplify down to an I, but I can't take the square root of 3. So there are 2 imaginary roots there. And when I subtract 4 here, and I take the square root, don't forget your plus minus sign, I get x is equal to plus and minus. The square root of 4 is 2, so it's going to be 2i. So I have 4 imaginary roots. If I had tried to graph this, I would have not found any roots at all because there are no real roots. There are all 4 imaginary roots there. So make sure you understand that if that's the case and you graph something in your calculator, in fact, let me do that real quick just to show you what that would look like. So it'd be x to the 4th plus 7x squared, and then plus 12. And I may need to change my window a little bit just to make sure I can actually see the graph. Negative 15 to 15 is a good place to start. Negative 10 to 10 is fine as well. Just kind of gives you a general idea. Okay, I'm graphing it and I'm not seeing anything. And it's because it's off of the graph. Okay, so if I go to my data table, I might be able to see some value. So at negative 5, it's way up at 812. Okay, so I do have some here. I do have a y of 12. So if I go back to my window, maybe I change my y's to like negative 50 to 50. And then when I graph it now, I should see something up here. And that's what it is. I have 4 imaginary, I have no real roots, and that is what that would look like. Okay, let's do another one. Number 5, I have factors of 12 would be 1, 2, 3, 4, 6, and 12, all over factors of 2. Now, it didn't ask me for these, so I'm just writing them so I can think through them as I graph it. So let's go to the graphing calculator and graph this. And it is 2x cubed minus 3x squared plus 8x minus 12. And then remember my window is kind of set at really big values here. So let's just go back to 10, 10. Okay, graph it. And now I know I can think through the possible rational roots, and let's see if we have any. Okay, when I go back here, I could have something as big as 12 or negative 12, but everything else should be smaller than that. So what is going on here? Okay, so on the graph, I have 1 root. Is there a root between 1 and 2, it's positive, that might work? Maybe 3/2. I think that was on our list. So yes, 3/2, which is 1 1/2. Okay, so what I'm going to do is see if that will work for me. So second, calc, press enter to test a value, and I'm just going to do 3 divided by 2. And yes, it's a root. So 3/2 is a root. So that means what I'm going to do is I'm going to go back and I'm going to say 3/2 is what I'm going to use in synthetic division. And I only need 3 roots. So once I do synthetic division once, I'll get down to the quadratic. So I have 2, negative 3, 8, and negative 12. So bring down your 2. Now, 3/2 times 2, the 2's will cancel and leave me with 3. Here I get 0. 0 times anything is 0. Add, I get 8. And then 8 times 3/2 is going to be 24 over 2, which is 12. And 0 is what I get. Now, b is 0, so I can use square roots to solve this. So remember, this was x cubed, making this x squared. That's really important you understand. You have 2x squared, and then no x plus 8 is equal to 0. So I'm going to solve this. The first thing I would do is I would factor out the 2, the GCF. So when I factor out 2, that leaves me x squared plus 4 equals 0. This is not going to give me a root because there's no x to solve for, but when I set x squared plus 4 equal to 0, I get x squared is equal to negative 4. I use square roots, plus and minus. The square root of 4 is 2. The square root of negative 1 is I. There are 2 imaginary roots and then 1 real rational root. And you need to start thinking about how to classify those. Okay, I want to make sure we get some done from each section, so I'm going to move on to the next little section. So find all the remaining roots here. So if I is a root, so is negative I. So it's kind of like 0 plus I. This is complex form. Its complex conjugate is the opposite sign for I. So I'm just going to use I and a negative I in my synthetic division. And there's a lot missing here. So I have a degree of 4. I don't have a degree of 3, so I have to put in a placeholder. I have a degree of 2. This is a negative 1 out front. I don't have a degree of 1, and then I have my constant. This is what makes this problem hard, is really this. So bring down your 1 and multiply. 1 times I is just I. Here I get I again. I times I is I squared, which is really what? A negative 1. So negative 1 and negative 1 is negative 2. Negative 2 times I is negative 2I. Here I add. And then when I multiply here, I get a negative 2I squared, which is really a positive 2. So I get these two will cancel out. Okay, then I keep going. Bring down your 1. 1 times negative I is negative I. These cancel. 0 times anything is 0. Add. Here I get a positive 2I. They cancel, giving me 0. This is x to the 4th, x to the 3rd, x squared minus 2. So I'm going to solve x squared minus 2, add 2 to both sides, square root both sides. X is a plus and minus square root of 2, and that will not simplify. So I have 2 irrational roots, and then my original plus I with the minus I that I knew to add. So 2 imaginary. So I have all 4 roots. Okay, let's do another one of these. Okay, I think I'll do this one because it's a little bit longer, harder, that kind of thing. So I'm going to say 1 minus 2I, but that means I also have a 1 plus 2I. And then I'm going to set this up. And I have a 4. I'm missing my degree of 3. I have 2. I have 1. So I only need a placeholder for the 3. That would go right there. So I have 4. I have 0. I have 17, 14, and 65. And then I bring down my 4. And I can use my calculator for this. So it's going to be 4. Not here, though. I got to get out. So second quit will always take you out. Clear everything out. So I need to do 4 times 1 minus 2I. Okay, and that's going to give me 4 minus 8I. It's just like distributing. So 4 minus 8I. And then when I add, I get 4 minus 8I again. And then I'm going to use parentheses here and here to multiply. So 4 minus 8I times 1 minus 2I. So 4 minus 8I times 1 minus 2I. I hope I did all that correct. I did it quickly. And then I get negative 12 minus 16I. So negative 12 minus 16I. And then the 17 and the negative 12 are actually what you're adding. So you get 5 minus 16I. Now multiplying this times this. So 1 minus 2I times 5 minus 16I. 1 minus 2I times 5 minus 16I. And I'm hoping this gets a little bit smaller at this point. I have no idea. Oh, it didn't. Negative 27 minus 26I. Okay, and here I'm adding these two values. I'm going to be adding those together because there's nothing to add to the negative 26. So I get a